Hi, Happy New Year. Welcome everyone to our seminar series on trustworthy data science and AI. This is Jen Pei. Together with we have professors Jianan Wang and Tianzheng Wang. And today, this is the first talk in this year. And today we are very, very happy and lucky to have Dr. Haixun Wang to give us a talk. And Haixun has been a longtime friend of me and also as SFU. He visited SFU at least twice, I remember, even to say over 10 years ago. And Haixun is a very rare kind of IT experts working on both academia and industry. And he is currently a VP of Engineering and Distinguished Scientist at Instacart. And before that, he worked at WeWork as a VP of Engineering and Distinguished Scientist, and also worked with Facebook, Amazon, Microsoft, IBM, all those big names, and Google, of course. And then his work has spanned many different areas, starting from relational databases, data mining, temporal data, spatial data, to natural language processing and recommendation systems, knowledge graph, cover almost every frontier in the last 20 years in knowledge and data engineering. And in terms of academia achievement, his research work opened quite a few new problems. His papers have been cited over 22,000 times so far, according to Google Scholar. And I believe many of our faculty members in academia may not have this high number of citations. So Haixun received the PhD degree in computer science from University of California, Los Angeles in year 2000. And he published over 150 research papers in academic journals and proceedings. And without further ado, let's welcome Haixun. Yeah, Haixun, the stage is yours.
Thank you very much. Thanks, Jen. Thanks for the very nice introduction. So I'm really glad to be here, especially, as Jen mentioned, I've been with, have visited, SFU twice. And so I'm happy to give this talk about, some of our recent work, but mostly our some of our thoughts, visions, in this domain of e-commerce search, right? So e-commerce has been, of course, has a very long history. People have invested in this domain. A lot of people have done a lot of research in this domain, and it's also an area that's that is still seeing a lot of growth after so many years. So Instacart, of course, is a e-commerce company, and the e-commerce company that focuses on mostly groceries, although we're also expanding to many other areas. So I would just use this opportunity to introduce some interesting problems in this area. This is not going to be a very, very technical talk. It's more about what are the problems there, what are the potential solutions, and maybe we can do some brainstorming of this. All right. So these are the people who are actually involved in some of the work I present here. They are, but they are part of this, Instacart search team. The search team is, of course, we have more people, much more people than the people here. But they, these people, they help with the work that I'm presenting in this deck. So here's the sort of like agenda for today's talk. So I will start with some description of our business, and the challenges in this business, like combining, e-commerce with delivery, and in the domain of grocery. It's actually a very unique combination. And then I will talk about classical information retrieval, how we build this e-commerce search engine. It's nothing really special, like classical IR, of course, is already quite mature. And then, I'll talk about, the challenges there. Usually, unlike, web search, like web search companies like Google, they really have a lot of resources. They put a lot of resources into, improving their search engine. But usually, e-commerce company, including Amazon, does not really have that much resource in, working on search, right? So, what is the best way, of improving search? So people are always looking at the latest technology. And of course, neural network, deep learning has been very, very important, critical in improving everything that we do, in this, in machine learning, and of course in the IR space. So I will talk a little bit about the neural information retrieval. Then, I will introduce some new ideas in this domain, and what we call a model-based information retrieval. It's not something that we have implemented or put into production. It's mostly just some very initial design and some very primitive thoughts I would like to share with the audience, and see, if this is something that is meaningful. But in reality, what we are doing is what we call a hybrid approach. So a combination of the classical information retrieval and neural information retrieval. So that's our current status, and I will also say a few words about it, and then I will summarize. All right. So Instacart is in this mainly in this grocery business, and turns out that this industry is really, really very big. So the global grocery market is $5.7 trillion, and in the US and Canada alone, it's $1.3 trillion. That is really, really very big, right? In comparison, the consumer electronic market is about $400 billion, and books and magazines, pretty much where e-commerce started, is only like $25 billion. But remember, just for US and Canada, grocery is a $1.3 trillion business. It's so much bigger, right? So there's a lot of opportunities there. But on the other hand, at least at this moment, the market penetration of grocery is actually still very, very small. This is 2019, before COVID, right? So, consumer electronics, 47% of the sales happens online. Books and magazines, 32% happens online. Grocery, 3%. That was the number before COVID. And then, of course, COVID happened. The pandemic happened, and it jumped, from 3%, I mentioned in the previous slide, to 10%, right? So the projection, because of this pandemic, changed quite fundamentally, right? So the bottom curve is, without COVID, that's what people think is going to happen, and the line above, is what's happening right now. So 2021 is 12% of the grocery shopping is already happening online, and we expect that this growth will continue. So that's how massive this is going to be. There are a lot of interesting challenges in a business like Instacart, because Instacart actually works with many retailers. We have over 600 retail partners, right? So each retailer, each of our partners have many stores, right? So we need to we send our shoppers to all these stores, and they pick pick the groceries on the shelf, and then they send the groceries to our final customers, right? So the most important question the problem we need to solve is like, we need to figure out at a certain point of time in a particular store whether a certain product is available or not, whether this product is on the shelf or not. Right? This turns out to be a very difficult problem because the retailers, the stores, they don't have this kind of information. They cannot, give us this real-time inventory information so that we can, integrate and manage them, and then we can use that kind of information to guide our shoppers and to do those logistics, right? We don't have that kind of information, and also things change, like because usually it's kind of flexible. You made some order online, but the delivery could be at a different time, right? And the availability changes, right? When you place the order at 8 in the morning, the availability is one kind of situation, but 5 p.m. it's in a different kind of situation, right? So we really want to know at any point of the time, in any store, any product, whether it is available or not. So one signal we have is like, because we are sending out so many shoppers to all different kind of stores, so they give us information like whether they are able to find one item or whether they are not able to find one item, right? So we have this kind of information, and then we can just look into this kind of data, the historical data. We know over the year how many times at a certain hour, right? This particular time is available on the shelf or is not available on the shelf, right? So we have this kind of information. So this is just for one particular item, and you see there's a big gap in the middle. This actually means this item is seasonal. So somehow during these period of time, the stores don't carry this item. But on the other days, you have these statistics like found and not found, and how these kind of thing change over time, right? So we build statistical models trying to figure out how likely our shopper will be able to find some item at a certain hour in a particular store, right? But of course, this is still very brittle, especially things change. Things could change unexpectedly, right? So recently, as you know, there's a big disruption of supply chain across the, at least in the US, there's a big disruption in the supply chain, and a lot of things becomes unavailable, and that is a problem to our model. And recently, people, we can buy, this COVID test kits online, and a lot of people are trying to buy COVID test kits online. But usually, these kind of things go out of stock very fast. So when you send people over to actually, buy those things, they cannot find it, right? So all these kind of things create a lot of challenge to build a very accurate model to predict availability. So this is actually one big challenge we are facing at this moment, right? But there are also a lot of opportunities. The opportunities about predicting how likely you will buy a certain item again, right? So, for example, bananas. If you buy bananas on day 0, how likely you will buy bananas on, the following days, right? So we can put together this kind of, curves, like on the x-axis, it's actually the log of days, and then we sort of know, like, okay, so it's like 7 days or 10 days after you bought banana last time, how likely I should, recommend banana to you, right? So we have this kind of distribution. This is kind of interesting. You cannot really predict, when, if you buy a coffee maker today, how likely you will buy another coffee maker, in 3 months. That's much more difficult to predict than, predicting, whether you are going to buy a banana again. Right. So this is the opportunity we have. So when people buy these kind of things over and over again, and then there's also another very, very interesting opportunity, which is voice commerce, right? Instead of doing this search online, make place orders online, how about we just talk to a device and in this kind of voice communication, we place an order. It is very, very difficult if you are buying something like a coffee maker, because it's very difficult to describe what kind of coffee maker you would like, and also it's very difficult for the store to describe what kind of coffee makers they have. So there's a matchmaking process. But if you are buying bananas online, through this voice commerce, then there's really not that much you need to describe. Banana is a banana, maybe organic or not organic, but you are not going to compare this banana with that banana. So that actually makes voice commerce much easier for grocery shopping, right? However, this e-commerce is far from a solved problem, although people have been working in this area for so many years, right? So this is actually, Walmart. This is the Walmart app, right? So if you search for something like red wine, $30, this is what you get. Somehow these are not really red wines; these are yeast. Like, so I don't understand why the top 3 results yeast, right? And if you search for red wine, $40, somehow it becomes a different set of items, but still none of them is really red wine, right? So I also tried it on Amazon. Actually, I have a screenshot, quite a few years ago. That was July 7th, 2019, 2 or 3 years ago. So if you search for red wine $40, you get these shoes and pants and hairs, this hair extensions or whatever. Actually, I looked into the reason why you search for red wine $40. They give you something like this. One thing you notice is that the color, all of them have the same color, because there's a color called wine red. So all these items, they have the color which is labeled as wine red, but they don't understand what is red wine $40, and that's what is returned. And then you search for red wine $40, you have something different, but at least for these 2 watches, you can see the color probably also is red wine. Wine red. So that basically is an indication, like, although Amazon has been doing this for so many years, they don't really understand the query. If you search for red wine, no problem, because they remember this query. Red wine, if you search for red wine, these are the things you click, these are the things you buy. They just do a lookup and they know what are the things they should show it to you, right? But red wine $40, suddenly it becomes a tail query. And for tail query, you have to rely on query understanding and all these kind of things, and everything is off, right? Instacart is at a very, very early stage. We only have like a very, very few people working on search, on query understanding. So we also have lots of problems. Red wine $40, sort of like we are returning the red wines, but if you search for Apple iPod, this is Walmart on Instacart interface. We actually, although we, sorry, although Walmart actually carries Apple iPod, but because we are mostly doing, grocery, and we are interpreting this Apple as the fruit apple, right? Also, again, everything is off. So we are definitely at a very, very early stage in this business. So recently, there's metaverse. Everybody is talking
Great.
about metaverse.
Looks like you need a good wine pairing. Take a look to your right. Your age has already been pre-verified through your profile, so no need to wait for an ID check. Just place the item in your cart whenever you're ready.
I would just stop here. So basically, recently there's a lot of discussion about the AR, VR, metaverse, and people are thinking about, what is the future of e-commerce? What is the e-commerce in metaverse, right? I'm not sure this is going to be the future, because it seems like it's still very limiting. We're still sending people to this virtual, grocery store, and they still have these aisles and all these kind of things. I'm really not sure, this is the way we want to naturally interact with a lot of very, very good wines or anything like that, right? But this is one direction, something we are looking forward to, what is the best experience we can provide for our customers in an online store, and maybe in the AR, VR, virtual situation. But one thing I can say is there's still a huge gap between buying things online and buying things in a real store. Typically people buy much more things in a real store than buying things online. I mean, grocery shopping, right? If you go to Costco physically with a store, you buy $200, $300 of stuff. You buy things online on Instacart, you buy $100. Why is that, right? So, apparently a physical store, although it's not really personalized for everybody, it gives you this kind of, environment which makes you buy more things on impulse, like something you haven't planned to buy. And when you are in the store, you look at you look around you and look at what other people are buying. You buy more things. You buy things on impulse. But if you shop online, you have something in mind. You buy these kind of things. So definitely there are lots of opportunities here. But I'm not going to talk about this very futuristic, ideas and solutions. I'm just going to talk about, how do we improve, information retrieval? How do we improve e-commerce search, right? So query understanding is a very, very important step. For example, if you search for blue long sleeve dress, you want to break down these queries into different components. You need to know blue is a color, and long sleeve means we are talking about the sleeve length, and we prefer the length to be long, and then dress is basically a product type, right? So there are at least two challenges. One is you need many rule-based or ML models to interpret the query, basically query understanding, but just knowing the meaning of the query is still not enough. You need a lot of data, typically data of heterogeneous types, like the data from catalog, data from taxonomy, or data from the knowledge graph, so that you can really ground those terms, whether this is a color, or this is an attribute, or this is a product type. You need to ground these terms into your catalog, into your taxonomy or knowledge graph, and then you will be able to get back the things you want to find, right? So this is our challenge. And this here is another example that shows actually a lot of things need to work together to make it happen, right? So let's say the query is California red wine 2019, $40. So we know, okay, the category people are interested in is red wine, but we are interested in red wine produced in California. So the location is California, and the year of that production is 2019, and the price is around $40. It's not exact $40, but it's actually a range where, you know, it's around $40, right? However, in order to make this thing work, in order to be able to get all this information, you need many machine learning models to work together. You need language detection, speller, stemming, lemmatization, classification, segmentation, anti-linking, query rewriting, query relaxation. You know, all of these could be, of course, rule-based, solutions, but they also can be, machine learning models, right? So you need to develop all these kind of tools and then make sure that they work together. This is how tedious or how demanding this query understanding task is, right? But the challenge here, at least for us, is like we need to deal with really a lot of heterogeneous type of data. Just look at product category and the taxonomy, right? So Instacart is working with more than 600 retailers, and retailers adopt very different product taxonomies. Each retailer is different. They have their own taxonomy because they are in sort of similar but different kind of business. Google a few years ago published this Google product taxonomy, right? So Google wants to work in the e-commerce domain, and they want to publish this taxonomy. They would like all these small business to conform with this Google product taxonomy, so it makes it easier for Google to index and to sell their stuff on Google's website, right? However, for Instacart, we have a taxonomy just for groceries, but this taxonomy is actually much richer than the grocery part of Google product taxonomy. Our grocery taxonomy has more than 6,000 categories, almost as large as Google's entire product taxonomy, right? So this is the type of the data we are dealing with. But immediately you will know, like when a taxonomy is so large, there's going to be many different kind of problems, because taxonomy is created by some humans, right? Some taxonomists created this taxonomy. Usually you can manage a taxonomy of about like maybe 100 nodes. Once it is beyond 1,000 nodes, there are lots of issues. So for example, in our taxonomy, we have these two categories, or these two type of nodes. One is indoor plants and the other one is potted plants. But if you look at the products that we carry, how do we know, like, there's really no reason to put one product in this category versus the other category, right? So, then it creates a lot of problems. So if you use this category, then you are missing something in the other category, and vice versa. So when you build taxonomies, there's no perfect taxonomy, because taxonomy is a tree structure, right? The way we organize things in our mind, or in the concepts in natural language, things are not organized as a tree structure. Things are organized as a graph. Everything get connected. So when you try to project this graph structure into a tree structure, all kinds of problems will arise. So it's not possible to do a very good job, to build a perfect taxonomy. It does not exist. But most e-commerce rely on a taxonomy, and that is to a certain extent a very big source of the problem. And then you know, a lot of e-commerce companies are currently working on this thing called the product knowledge graph. There's a lot of work in this domain. You know, my friend Luna Dong from Amazon actually did a lot of work, you know, in the last couple of years to build, you know, product knowledge graph at Amazon. And this is from her slide. You know, she was asking a very, very interesting question. So basically, what is the relationship between a generic knowledge graph and a product knowledge graph, right? You know, is a product knowledge graph a part of a generic knowledge graph, or they have some kind of overlap or intersection, or actually, you know, generic knowledge graph is a part of a product knowledge graph? This sounds like kind of ridiculous. How can a generic knowledge graph becomes part of a product knowledge graph? But if you think of it in a different way, assuming you have a generic knowledge graph, right? You have a lot of nodes, a lot of concepts in the generic knowledge graph. But for every of those concepts, for every of those nodes in the generic knowledge graph, you can perhaps connect it with some kind of products, right? And then this entire thing becomes a product knowledge graph. So in this sense, product knowledge graph is actually bigger than a generic knowledge graph, right? So this also shows like how difficult, how challenging this problem is, right? Now, why is this important? Because we would like those product knowledge graphs to be able to answer questions like, you know, insomnia, heartburn, how to get rid of a raccoon, right? So you basically have some need or have some kind of condition, have some kind of symptoms. You go to the web, you go to an e-commerce website, you want to find what kind of products can solve your problem. Right. So, you know, if you cannot fall asleep, you search for insomnia on Amazon. What Amazon currently gets you is, you know, basically books or movies and all these kind of things. Why? Because these are the only products that contain the word insomnia in their product name. Right? But there are many, many different products that are actually much better solution, you know, or much immediate solution relief for your insomnia problem. Like you have, you know, medicines, you know, supplements, or, you know, some kind of devices and all these kind of things. Nothing will show up here because their product names do not immediately contain this word insomnia, right? And you can of course think of many other queries like you know, heartburn and how to get rid of raccoon. You are not going to get very, very good results on a you know, e-commerce search engine. However, you know, if you look at the queries that contain the term how, this trend from Google shows like basically more and more people are asking Google like how to do this and how to do that. There's a big uptick, you know, I think this is the beginning of 2020, probably people are asking, you know, how do we deal with this pandemic, right? So people want answers, people want, you know, solutions. And currently, I don't think, you know, e-commerce search engines are giving people these solutions, right? So what we would like to have is like, you know, we have a knowledge base, and we have a knowledge base that can answer all these kind of questions, right? We have a key phrase. So all of these insomnia, heartburn, and how to get rid of raccoon, these are key phrases. And then for each of these key phrases, we have some kind of relationship. Like heartburn, one important relationship is like medicine for heartburn, and then we have a list of medicines associated with this key phrase and the relationship. 2017 sci-fi movies, and you know, the relationship might be top 10, you know, sci-fi movies, and these are the names of the movies. Depression, you know, if you search for depression, I would like to get, you know, all these real solutions, real help, and so if there's a relationship called treatment of, and then you get all these kind of things, that would be good answers for our customers, right? So this is sort of our dream. Like, if we have a product knowledge graph like this, we'll be able to do all these things for our customer. But this dream is like still very, very far away. Probably it's not going to, realize anytime soon. And the question here is like, is it worthwhile to pursue this game? So, because it's, it's so far away, right? It will take so much effort, right? And it's not just that, because there's a lot of knowledge on the web in totally unstructured format that is really very, very relevant to our business. So if you look at these two web pages, like 10 healthy snacks for children, 11 best barbecue recipes, these kind of things. We are grocery, e-commerce. People are coming to our website, and they want to look for not just the products but also ideas and sometimes inspirations. They want to look for really something that they can, some ideas that they can use, right? We're doing a lot of recommendations. But recommendations of groceries is not that interesting. Like, people know what is the, banana or potato or tomato. Recommending those kind of things to customer does not make a lot of sense. But on the other hand, all these groceries, these are ingredients for making something else. You can make a very, very creative dish, or you can prepare a very, very nice party, and all these kind of things. But these kind of things, need ideas, right? So how do you prepare a very, very nice dry force party? What are the things you shall get? Here we have all these kind of information on the web, but how do we, make the connection? How do we make this e-commerce search engine to be able to understand this kind of knowledge and use this kind of knowledge to help our customers? That is a very, very challenging problem, right? So to me, it's like, e-commerce search is like a big data integration problems. We have structured data, like a catalog, transaction data. These are structured data. And we also have semi-structured data, like, taxonomy and ontology and the knowledge graph. To a certain extent, we have these, but, of course, yes, we have quite a complete taxonomy, but knowledge graph, we only have a very, very, small piece of a knowledge graph. But we also have lots of unstructured data, right? We have, text data, these customer reviews, these web pages, and we also have a lot of, images or even videos and all these kind of things. So here, solving this e-commerce search problem is pretty much, equivalent to solving this data integration problem. But how do we, put all these things together and, so that people can access all these kind of information through some keyword queries? That is not solve the problem. Yeah, so summary. Currently we're using classical information retrieval, which basically use inverted index, and inverted index is term-based. There's no semantics. Red wine and wine red. These are just two tokens. They can match. The data token by token instead of with semantics, right? But if you want to support semantic matching, then we need to perform all kinds of query writing at the many levels. We need to group tokens together and do entity linking and all these kind of things. So we need to be able to create some kind of structure out of these keywords, right? And then we need to develop many individual machine learning models, as I've shown in the previous slide, right? And then in order to be able to understand all kinds of queries like insomnia or these kind of queries or depression, these kind of things, we must incorporate a heterogeneous type of data such as information on the web page. And then interesting thing happened is like the entire NLP industry, machine learning area is working on deep learning, working on neural networks. So a very, very natural question is like how neural network, how deep learning can help information retrieval, right? So a lot of neural network based solutions have already been introduced to the field of information retrieval. So there are lots of neural re-ranking models. So basically in information retrieval, there's this very important step called ranking, and using machine learning, we do basically it's called learning to rank, right? Using machine learning to do the ranking. And then we can replace some traditional machine learning algorithm that we use for ranking with neural network based machine learning models, right? So this is what is known as neural re-ranking, right? And then we are because we are getting into this neural network domain, and there are very important thing we should focus on is actually representation learning. So you need to be able to encode queries and documents into distributional representations, basically embeddings, right? And then during the real time, you are going to do a nearest neighbor search or approximate nearest neighbor search so that you can match those queries and those documents in the embedding space, right? So this is actually a nice picture summarizing this. So, in offline, at the offline stage, you have a lot of, products or documents you want to, represent them into this embedding by embedding the distributional representations. And how do you do that? You have a deep neural network, and then you going through this deep neural network, you convert, this product to a learned representation, right? And of course, in order to do that, you need to have a lot of context, and this context could be, information in the product catalog or the user engagement data, things like that. And then, and this step is called indexing, right? So you convert all these products you have offline into a set of embeddings, and then you use, some kind of, approximate nearest neighbor solutions to index those products. And then when a query comes in, this is real time. You put it, you feed it into another neural network, and it converts this query into a distributional representation in the same space. And then in this space, you already have an index. You find the nearest neighbor, for this query, and this is sort of the retrieval step, right? A lot of work has been done in this area. If you search on the web, you will find things like product to Wang, product to bird, and eBird. eBird is actually e-commerce bird. So people are already using these solutions for e-commerce for retrieval and for ranking, right? And it's not just about search. In the area of recommendation, intent prediction, people are also doing this. This neural information retrieval has become very, very popular in the recent years, right? And there are a lot of work done in this domain, like by big e-commerce companies like JD.com, Walmart, and you have end-to-end personalized neural network information retrieval system. And this the paper on the right-hand side, instead of personalized, it has a session-based, not just one single search, but the entire session. Use the entire session data to optimize this neural information to optimize this information retrieval. But the interesting thing here is like, you know, in the title, this word or this phrase, you know, end to end. So that is actually very, very interesting, because that's actually one of our goals. And the question here is like, instead of building so many different models and trying to very, very hard to make them work together, is it possible to have this end-to-end solution, right? I remember a few years ago, I was talking to a senior executive of e-commerce search company, and his exact question was like, is it possible for us to use, you know, one single machine learning model so that we can do, you know, information retrieval end-to-end? Right. So this is actually a very, very important question. At that time, that was like maybe 5 or 6 years ago. I don't think there's anything there. Even now, of course, we have gone very, very far in this direction of deep neural network and neural information retrieval. We can answer this question better, but I don't think we are there yet. There's still a long way to go. But what I'm trying to say is like, for queries like insomnia, heartburn, or how to get rid of raccoon, it's more about data integration than query product semantic matching. When you talk about query product semantic matching, you are assuming, in your catalog, in your taxonomy, in your knowledge graph, you have all the information you need, and you have all the user engagement data you need, and then you can do the semantic matching. But the reality is that, in order to be able to answer these questions very well, you need a lot more information, right? So let's seriously talk about the end-to-end information retrieval, not just using a neural network algorithm to replace a learning to rank algorithm in a very, very local ranking process. So the question here is, can we train one machine learning model that returns related documents and products for a given query, right? Just one model. So recently, I think it was either last year or the year before last year, there was a paper from Google, which is titled Rethinking Search. They are basically asking this question for web search, right? So typically, usually you have the query, you have retrieval, you have ranking, and then you get the result, right? And usually this thing only answers one type of question, like either this is a keyword based search, or this could be complemented API, like you return related product or things like related documents or things like that, or it could be question answering, right? But here the question here is like how about we just build one model, and this model will be able to answer any type of question. So this black box model will be able to do that, right? So this is the motivation, and this is the paper, Rethinking Search, making domain experts out of data types. So, you have a model, this is the model they want to build, and it can handle all different type of tasks or query, home modeling, home remodeling, right? And given to this model, it returns you a set of documents. So, here are the document IDs, and it also can work on question answering. When was Abraham Lincoln born? The answer, right? And the related documents and even summarization. So you build this huge model, whatever it is, it will be able to answer all these kind of questions for you, so that you don't have to build dozens or even hundreds of models and trying to make them work together, which has been so difficult as people working in the e-commerce search domain have found out. However, there are very, very big challenges here. The challenge here is like, remember, the goal is like, given a query, going through this model, I will return the model will return the IDs of those documents that satisfy this query, right? So the document space is huge. Google indexes 30 trillion pages, right? And there's also a huge amount of new pages coming into the picture every day, right? It is estimated that Google crawls 25 billion pages every day. So this is a huge space. How do you represent those IDs, in the a neural network model? That is sort of like unthinkable, like 30 trillion, IDs. That's really, really very, very difficult to manage. However, maybe e-commerce is a much better opportunity. So it's much more feasible to do this with e-commerce search than web search. The reason is because e-commerce is much more closed than web search. Instead of searching for searching against like 30 trillion pages, e-commerce is more like searching against a product database. Right, so the domain is much smaller, and we probably only have like a few million products, and this is definitely true for grocery search. There are not really that many products out there, and the space is really quite small, compared with web search. For ads, this is even smaller because only a very small subset of products are so-called featured products. Featured products are the products the advertisers are paying for us to show to the customers, and usually we have like thousands of this instead of millions of this, right? So if we are only talking about thousands of products, or 1 million or 2 million products, it is much more likely that we can represent them as tokens or IDs in a neural network system. So, but there's also a very interesting approach, like very similar. This is what is called neural databases. This is a paper from Facebook, and they introduced this very interesting idea. The reason I want to mention this is because we are sort of trying to look at the problem from a different angle. So we think of web search as information retrieval against a huge number of documents, but e-commerce search instead is information retrieval against a database. Instead of like trillions of pages, we are searching against a relatively much smaller size database. So neural database is sort of something trying to unify information retrieval and database management, like search over databases. What they do is like they represent the information they are trying to manage is like a set of facts in natural language representation. Like Nicholas lives in Washington, D.C. with Cheryl. Cheryl is Nicholas's boss, and all these kind of things, right? And then they try to support natural language queries like this, but it's not like fact by fact. They need to support joins of different facts, and they need to support aggregates over joins or over this data set of facts, right? And supporting those joins and aggregates makes it totally non-trivial, right? However, there's also another big problem in this approach, which is it does not scale very well. The solution provided is they are using transformers. They are using BERT, for example, to index all these kind of things. BERT can support a database of maybe hundreds or thousands of of facts. But remember, like a bird is a quadruple in complexity. So it means like it won't be able to support, search, against a database of, thousands or, millions of facts. That is just not very, very possible at this stage, right? Okay, so here, what we would like to do, as I mentioned previously, e-commerce is trying to deal with this problem of handling, heterogeneous type of data, right? So we have structured data, we have semi-structured data, we have unstructured data. What this industry has been trying to do over many, many years is trying to convert those semi-structured data or unstructured data into structured data, right? And then it tries very hard to convert a query also into a structured representation. So you have structures on both sides, and then you can do some kind of matching. So structure to structure matching, and you get the results. But unfortunately, it's not very, very easy, right? Understanding query is not very easy. Representing, doing a lot of information retrieval, information extraction from these unstructured data and turning them into structured data definitely is not easy, right? Here, we want to go the other way. Instead of turning these semi-structured data and structured data into unstructured data into structured data, we want to turn all these data into text, into unstructured data, right? So we turn these tables into text, and we'll show how do we do that. And we turn this knowledge graph into text, and then web pages are already in text. Then we only have one uniform representation, which is unstructured text. So then another thing we need to worry about is like, we need to create some IDs to represent documents, represent products, and we embed those IDs into the text as if they are just, some part of the vocabulary, right? So we create a special token for each product and use the token in text to represent the product. So we can say P123, that is a token, representing a product. P123 could refer to a specific product, right? An alternative approach is like, we use some kind of special token to mark the beginning and the end of a product name, like this Haixun milk with reduced fat. We use these two special tokens to indicate that they are actually a product. One issue with this soft representation is like, we cannot guarantee like the data generated by the machine learning model will be exactly, it will be a real product, right? Because it's just something generated by this generative model. So in this presentation, I'll go with the first approach, assuming we are going to use these special IDs, special tokens to represent each product. Right now, our goal is to unify heterogeneous data to text. So let's start with structured data. So basically, we think of structured data as relational tables with columns or attributes. And we assume each record is about a product. And then, here, the first step we're trying to do is basically create a lots of, natural language templates for each attribute. And this template allows us to generate descriptions of product in a natural language. So product name, this is a certain milk with reduced fat. And then we can say, we have a template, and then the template says, oh, the product ID of blah, blah is P123, right? And then we have, other templates, that talk about the brand name or other attributes. And we can also have some kind of aggregation. So assuming we have all these kind of templates, we use all these kind of templates, we put things together and we convert them into natural language text, right? And then, of course, we have a lot of transaction data we need to take into consideration. This user engagement data is really, really important for e-commerce, search. And then, we can say, oh, the top converted items for certain queries, blah, blah. And a customer buy this thing, will buy other things, and all these kind of things. We also represent them in, natural language, representations. So we connect all these things together. And then, product knowledge graph, ontology, taxonomies, we can treat them in similar ways, generate some kind of, descriptions across multiple tables, and in a form that they are likely going to help us answer questions, such as complementary products and all these kind of things. So we are going to do this. And then, a web page, totally, unstructured data. This is actually simpler. What we do is we do, entity linking. We perform entity linking on these web pages, and then, entity linking allows us to connect some mentions to our product database, and then we represent those mentions by an ID, right? A predefined ID, and then we have a natural language, document in natural language, which talks about this particular ID, right? All right. And then we can pre-train, a huge language model using these natural language, data. Like we have an import sentence, P123 is a certain type of milk, and we do some kind of masking, and then the goal is try to predict the original import sentence based on the masked sentence. All right, then we need to do some kind of fine tuning. There are so many different ways we can do the fine tuning, because we are doing a lot of things, in e-commerce search already, like document retrieval. We have this training data. We know, given this query, we are supposed to return this type of products, and we can use this information to do, fine tuning. And we can also use other interfaces for fine tuning. And this is recommendation, document recommendation, or product recommendation. So basically related products. This is another way of fine-tuning the embeddings. And then, we have document encoding. This is yet another way of doing fine-tuning. We can also doing all these things together using, this so-called multitask learning solution, and we put all these things together. All right, so this is not something that we have implemented or not to mention like productized. This is something in an earlier design phase. We want to get an idea of whether this is even possible, whether this is even feasible, right? We already have some hard questions we need to answer. The first question is, what about the personalization, right? So personalization is so important for e-commerce search, but unlike the fact that you only have limited number of products, you actually have a huge number of customers, which is much more, bigger in size than the products you have. How are you going to represent them so that we can actually do personalization and customization, right? One possible solution is like you discretize this personal customer space into a fixed number of buckets, and then you have representation for these buckets, and then you associate the behavior of people in these buckets with those products. That's one way of thinking about it. And the other thing is, like I mentioned, using templates to convert, structured data, like tabular data, into natural language representation of those entities or products, right? But apparently this could be very biased. this really relates to how many templates we have. Why do you choose this template over that template? How are you going to be able to connect, concatenate all these representation together? Are you going to use a fixed order or whatever, right? And all of these operations will introduce a bias into your representation. So that is a question we need to answer. And then, finally, like pre-training a very, very large language model will take a lot of efforts, a lot of computation, a lot of cost. But it's unlike, training a language model for the English language. Once you have these tokens, there are new products coming into space and new customer behaviors and all these kind of things you need to take into consideration. So that is yet again, yet another, important question we need to answer. So currently, as we are still thinking about these questions, trying to come up with a reasonable solution and that we can execute on. At this moment, our search, backend, our search system is a hybrid system. We have classical, information retrieval, and we also have neural information retrieval. The neural information retrieval helps us to, have high recall. We don't want to miss something that, classical information retrieval, like the term-based solution, will definitely miss, but maybe the embedding-based approach will get us those items. But we still need, classical information retrieval for precision, for ranking, because neural information retrieval usually the results are very, very noisy, right? So this is the current status. I think this is all that I have. So as a summary, e-commerce search, very challenging. The challenge is really about dealing with heterogeneous type of data. You need to understand all these kind of things before you will be able to answer those keyword search queries very nicely. And at this moment, hybrid approach is probably most realistic approach, relying on neural network for high recall and then classical approach for precision and the scalability, right? And, end-to-end model-based information retrieval is very, very attractive. What we have seen what, very, very large language models can do, like, BERT, GPT-3, if we can apply these things, apply these machinery on, e-commerce search, that will be actually very, very wonderful. All right, that's all I have. Thank you very much.
Yeah, thank you very much, Haixun, for the very insightful talk. So now let's open for the questions. And there are already one question in the chat area. It says, thanks a lot for the presentation. I have a question on the re-ranking phase in information retrieval. I suppose people will add some business metrics in the final ranking phase. I wonder if you can share some insights on what the most important factors in the final ranking phase.
This is a very, very good question. Interesting at this moment, at least for Instacart, our ranking only have one metric, which is relevance. We try to make sure our answers are very, very relevant to the query. I'm not talking about ads, right? So we are also showing ads as our in the results. So I'm only talking about organic search results. So the organic search results at this moment is totally gold on relevance. We just want to make it relevant. But it is very true. We are able to actually incorporate other business goals into this into the results, right? So, for example, we can rank those items like that have a discount at this moment at the top. And then you see something on the top, and you see there's a some kind of a promotion. It will increase the probability of conversion, right? So if we want to add conversion as a secondary goal into ranking, then this is the way of doing it, right? But it's not just about conversion. For example, I just want to make influence the people so that they buy more expensive items, right? So maybe this will improve, the size of the basket and all these kind of things. So I want to incorporate the price of the items as part of this this goal in ranking. And then if you make these kind of adjustment, and then the size of the basket is going to become larger. Also, you can take into consideration the different types of customer. This customer is very, very price sensitive. This customer is is only interested in organic type of products, right? And all these kind of things can be incorporated into the goals of ranking, and then you maximize those business goals as well as the relevance in ranking.
Great, thank you. So any other questions? Yeah, please feel free to unmute you and just speak out.
So Haixun, I'd like to ask a follow-up question. So you mentioned you want to incorporate, combine the relevance and also the business goal. And in the end, how are you going to evaluate your search result? Because here you mentioned the recall precision and the scalability, but there could be some other business-related metrics. And in the end, how can you consolidate all the metrics? And then,
right. So this is a very good question. So if we want to launch something at this moment, we need to track a lot of metrics, and relevance is one of them, and all these other things are the metrics we want to track. So as an A/B test, it's not too difficult to track all these metrics and to see if your new model is a good model, right? But for offline, when you are developing these machine learning models, the ranking solutions, how do you make sure you are doing the right thing? Usually we at this moment we are doing it in a separate stage. So the ranking model is only optimizing for relevance. So for that we have a lot of data, offline data that enable us to evaluate those models. We know how whether the results are relevant or not, right? And then we have something on top of that, doing some kind of adjustment on the ranking results based on some other metrics, like whether the price is a consideration, or whether discount is a consideration, or conversion is a consideration. Typically, that's going to be a little bit more challenging because we don't really have offline metrics for these kind of things, and we'll rely more on the A/B test for these solutions.
Thank you.
Any further questions? Again, feel free to unmute yourself and speak out. Have the conversation directly. Yeah, indeed. Actually, I have one question. I think you mentioned that the more and more people are asking for how instead of just about the product in question. This is a very interesting trend. I think that people are. One critical difference between traditional store and the online store is that in a traditional store, people tend to go directly into products. Because anyway, the only thing you can get is products. But in online store, more and more people are trying to get solutions. They try to get those solutions happen to use some products, right?
Mhm.
And so the content becomes very, very important. Do you have any comments on how the content, what's the role of contents in e-commerce, and how we can technically measure the users' trust on the content?
By content, you mean like, for example, all the information we have about the products, like a product.
Let's say how to use the product, whether how these several products can be used together to solve the problem.
Yeah. The biggest problem is like we don't have a lot of this type of information, and in cases like we have this type of information hasn't yet been very nicely incorporated into our search engine so that they can be used to answer these questions, right? So maybe a device, in its description it says this can be used to the main usage of this device, like, is actually to help relieve insomnia. Like maybe there's a description like this in the product, but this kind of information is not used at this moment. Even Amazon is not using this type of information. And this again is basically one of the challenges I mentioned in the current e-commerce search environment, is like we need to convert all these unstructured data into structured data so that we can make the connection. This is actually relieving insomnia. So there's a connection there, right? So recently we also tried something sort of similar, like in a lot of a grocery, there's a package like, this is like frozen food or something. Like on the back of the package, it describes the directions of preparing this food, right? So first step, second step, and maybe you also need to add some other ingredients and all these kind of things. We try to do information extraction from these descriptions, and then we can let customers know, if you buy this thing, you probably need to buy these a few other things as well. So together, you actually can make something out of it, right? Otherwise, you are missing one ingredient, and you only find out when you already checked these things out. So this is relatively simpler, but again, it's about converting unstructured data into structured data, and then using this structured data in keyword-based search. It's still not very well connected at all. So things don't work very well at this moment.
Great. Yeah, thank you. Yeah. Okay. The last call for questions.
Hi, Dr. Wang, thanks a lot for the presentation. Very informative. I have a question about the end-to-end model, your third conclusion here.
Yeah.
So as for now, I think in the model throwing phase, we still need do the cleanup first and then do the ranking. So I was thinking like for the end-to-end, can we start from the training? So let's train the retrieval model and the ranking model, or even the re-ranking model together, but we separate them in the model serving. That's something I'm thinking. I wonder if you think it's possible, or do some idea on it.
I'm not sure I fully understand. So currently, we are doing things separately. So we train those representations, independent of this other models, right? Like core understanding models and all these kind of things. So and then we combine the results of the retrieval, and then we go through the ranking. In the ranking phase, we have multiple models. Some of them are actually neural network models, like learning to rank models. and we have several level 1, level 2, level 3 ranking and all these kind of things. So these are still quite separately. I'm not too sure, like, what do you mean by training them separately, or you have something different on your mind?
Yeah, I mean, like, can we train the retrieval model and the ranking model together, like a joint training? But we separate in the inference time. So that's something I'm thinking whether.
Yeah, that's really one of the goals of doing that. Like doing end-to-end, right? So the biggest a step we need to merge is actually retrieval and ranking. But it's not that easy. Like if we think of this as a huge language model, we can just like treat it as like a GPT-3 and all these kind of things. We ask anything we can think of, and it is supposed to tell us something, right? But if you specifically want to merge these two models together, then you need to know like how are we going to be able to train these things together? Like how do you do like a back propagation, like that actually connects these two steps? The database retrieval is not like a differentiable. It's not like something can be trained through back propagation. So explicitly combining these two steps will be quite difficult. A lot of people have tried this, like for example in conversational AI, right? So question answering, and of course you can ask about many different things, and like chatting, and just a language model will work well. But if you actually have a relational database at the end, like you are asking whether this hotel has a room available, and with 2 king size beds and all these kind of things, then you need to look it up in the database. And there's a lot of work of trying to make this search like approximate, like almost like a text-based search. And the purpose of doing that is really to make this process differentiable, so that you can use back propagation to train this the entire step, right? So I think that's the difficult part if you want to combine these two steps.
Yeah, thanks a lot. I think that, learn a lot. Yeah, thank you.
Great. Yeah. Again, thank you so much, Haixun, for the great talk. It's very insightful and informative, and I really love that. Yeah, and also I believe the audience also got a lot of information there, inspired. Yeah, thank you again. So thank you all for attending this talk. And in this semester, we have quite a few wonderful talks like this one eyeing up. Next month, we will have Dr. Jingren Zhou, Senior Vice President of Alibaba, who will give a talk. And we will send out the official announcement soon. Please stay tuned. Okay, let's thank you, Haixun, again. And
thank you very much.
Yeah.
Thank you.
Thank you.
Bye.
Thank you. Have a nice day. Thank you. Bye.